Right, so the first question, that is question 4.1, you are given that diagram and you are supposed to use it to determine the value of x. So you can see that on the diagram I've got some angles that are labeled and some of the angles are in terms of x, right? So first thing, we need to find the value of x. So here, in this diagram, unfortunately, uh, there is a mistake in the diagram, right? Or rather, I would say it's not a mistake, it's because 4.1.2 says determine if EF is parallel to GH. So, before you start doing 4.1.1, you need to be aware that EF is not parallel to GH because it's not given there. So it's not a mistake that the diagram is drawn like that. So we need to find the sizes of, so rather the value of x. So my suggestion here is to use your knowledge of triangles. So I'm going to use triangle, I'll call it BCE. And then I'm going to say this angle B2, which is equal to 135, this angle here, it's an exterior angle of triangle BCE. So I'll say in triangle BCE, right, B2, which is equal to 135, is equal to 2x, or rather, let me write it first as it's equal to angle E plus angle ECB. I'll call it ECB. ECB is this angle here. That's equal to 75 degrees. But in this case, it's also given as C1. So let me just put it as C1. So the reason is the exterior angle of a triangle. Exterior angle of a triangle. All right, please, I'm going to repeat again that for this diagram, EF is not parallel to GH until you prove that the two are parallel in 4.1.2. All right, so B2 is 135. So put my 135 degrees, it's equal to angle E, that's 2x, plus C1, that's 75 degrees. Then, if I subtract 75 from 135, I'll get 60. So my x is going to be 30 degrees. Okay, so mark your work there, right? And the way that you mark your work is to do it this way. Give a mark for that, give 1 mark for the reason, right? This reason 1 mark, and that statement 1 mark, and the answer 1 mark. Okay. All right. Okay, let's carry on. If you don't have this statement like that, you can also give yourself a mark if you wrote it like that. All right. Is there anybody who has got any question there? Any question? All right. If you don't have a question, then let's move on to 4.1.2. Determine if EF is parallel to GH. Now, if you want to prove that the lines are parallel, and as you can see here, we have got straight lines. The best way is to prove that angles add up to 180, therefore they are co-interior, or a pair of angles are equal because they are corresponding angles, or they are alternate angles. So we are going to use co-interior, alternate, and corresponding to prove that those two lines are parallel. Now that I know that x is equal to 30, let me move on to the next page. So x is equal to 30. So what I'm going to do in my case, I'm just going to say, if I add angle B2 and this angle C2, I must get 180 degrees. If I don't get 180 degrees, then it means that EF is not parallel to GH, because B2 and C2, if their sum is equal to 180 degrees, I can say therefore they are co-interior angles. Alright? So in this case, I'm going to carry on that way. Alright? Okay. So what I'm going to say is I'm going to do is say B2 plus C2 is supposed to be equal to 180 degrees. So let me prove that, was under normal circumstances, if EF was parallel to GH, then B2 plus C2 must be equal to 180 degrees. Please, at this stage, I cannot write a reason and say co-interior. They are not co-interior as yet until I prove that they add up to 180, then I'll say they are co-interior. Alright? So B2 is 135 plus C2, that's 2x minus 15 degrees. The objective is for me to prove that the two angles add up to 180. If they do, then I can say therefore they are co-interior angles because they are supplementary, hence EF is parallel to GH. Alright? So this becomes... Yes?
I said for the reasoning it was angles on a straight line.
You said B2 plus C2 is equal to 180 because they are angles on a straight line.
Yes.
That's not correct. All right. Am I speaking to Kisha? Hello?
Yes.
Okay.
Yeah.
Kisha, I hope you are aware that we are trying to prove that EF is parallel to GH.
Oh.
EF is not parallel to GH because it's not given on the diagram. Okay? So we need to prove that EF is parallel to GH. That's the objective of question 4.1.2. So if you want to prove that lines are parallel, either you must prove that they are equal, then you say therefore they are corresponding or they are alternate angles. Or you must prove that if you add them, you get 180 degrees, then you say therefore they are co-interior angles, hence those two lines are parallel. Do you hear me?
Yep.
Okay, so the next step is to say 135 degrees plus 2 times 30 degrees minus 15 degrees is equal to 180. So this gives us 135 plus 60 degrees minus 15 degrees. I hope this is equal to 180. Then you get 195. 195 minus 15 will give me 180 degrees. Then I'll say therefore, B2 B2 plus C2, or rather I'll say, let me make my conclusion and say therefore EF is parallel to GH. My reason is to write co-interior angles supplementary, that is SUPP. Okay? All right. Now if you go to your acceptable reasons that I gave you under lines, can you all go there, please? I hope you have got your acceptable reasons for geometry. Right? If you go to your acceptable reasons under lines, the last acceptable reason it's about proving that angles are supplementary, therefore they are co-interior. Okay, so that's the one that I used here. Are you all there? Do you see the last reason under lines? Can someone speak, please?
Yes, sir.
Right. I'm sure you can see or you can read that it says if the co-interior angles between two lines are supplementary, then the lines are parallel. That's the one that I used here because we are not told or given on the diagram that EF is parallel to GH. Therefore, we have to use the converse of, of co-interior angles, which would be co-interior angles supplementary. All right? Is there anybody who has got a question? Okay, if you're silent, then I'll assume that there's no question. So let's move on to the next one. All right, so 5.3. So we are given the sizes of angle S1 and angle P1 in terms of x. So we need to determine, uh, first, we need to state the value of Q1 in terms of x. Now, before we move on, I want you to be aware that for this diagram, right, for this diagram, if you look at it carefully, right, we are told that it's a rhombus, okay? Since it is a rhombus, it means that the four sides are equal because it's a rhombus. That's our clue there. It's given. We are told that it is a rhombus, therefore the four sides are equal. All right? Remember your properties of a rhombus, right? All the four angles are equal in length. The diagonals bisect at right angles. It has two pairs of opposite sides that are equal in parallel. Okay? The diagonals bisect the opposite interior angles. Those are some of the properties, right? So, if I want to find Q1, and the other thing I want you to be aware that the diagonals are not equal. Okay, so Q1 is this angle here, right? Q1 is that angle. Now, the diagonals, when they bisect, or rather, the diagonals themselves, they divide the rhombus into two equal triangles. Okay? The diagonals, each diagonal divides the rhombus into two equal triangles. Therefore, triangle PQS and triangle SRQ are going to be congruent triangles. Okay? They are going to be congruent triangles. Right? You can do the proof as to why I'm saying they're congruent. Hence, this angle Q1 is going to be equal to 2x because PS is equal to PQ. So I'm going to write it this way. I'm going to write it this way. Well, it's just one mark. So 5.3.1, I'll say angle Q1 is equal to 2x. It's one mark here. So you don't have to give a reason. You get a mark for the answer only. How you get to know that Q1 is equal to 2x, there is no mark for that. Okay? So just write your answer straight away, nicely. It's Q1 equal to 2x. Okay? But you must know that the reason is because angle S1 and angle Q1, they are angles opposite equal sides. Because PQ is equal to PS. Because this is a rhombus. Alright? Then, from there now, let's calculate the value of x. Now, to calculate the value of x, there are many ways of doing it. Okay? There are many ways of doing it. In my case, I'm going to do it this way. So for 5.3.2, first I'm going to determine the size of P2. P2 is equal to P1 because the diagonal PR, okay, bisects the opposite angles P and angle R. So I'm going to say P1 is equal to P2, right? Then my reason would be to say that of rhombus. Okay, if you want, you can add right and say bisect opposite angle. Okay, so that's my reason why I'm saying P1 is equal to P2. Okay, then, so it means that P2, therefore P2 is also equal to 3x plus 20. Then I'm going to identify a triangle that I will use to determine the value of x. And my triangle is going to be PQS. So I'll say in triangle PQS, right? Angle P, which is equal to P1 plus P2, okay, plus angle Q1 plus angle S1, they add up to 180.
Sir?
Hello?
Sir?
Yes?
Okay. Q1 is not equal.
Sorry?
Q1 is supposed to be equal to this.
Can you come again?
Also, for Q1, 5.3.1, Q1 is supposed to equal S2, not 2x, which is this one. Because it's ultimate angle.
No. No. You're making a mistake there. Okay. Look here. I'm going to clarify this again. Do you agree with me? Do you agree with me that PS is equal to PQ?
Yes, sir.
Do you agree with me on that?
Yes, sir.
Do you also agree with me that Q1 is opposite PS?
Oh, I thought to be.
Right? And also S1 is opposite PQ.
Okay, yeah, I see now, sir.
All right, so you're okay now, right?
Yes, sir.
Okay, thank you. All right, so our reason here is going to be sum of angles in a triangle. Okay, then my P1, my P is equal to P1 plus P2, so when I write that, I'll say 3x plus 20 degrees plus 3x plus 20 degrees plus Q1, which is 2x, plus S1, which is 2x, they must add up to 180 degrees. So, I'm going to solve that equation. So, 3x plus 3x plus 2x plus 2x will give me 10x. 20 plus 20, that's 40. Then I'll take the 40 to the right. I'll end up having 180 minus 40, and that will give me 140. So my x is going to be 40 degrees. Okay. Right? So my x is going to be 14 degrees. Okay. Any question? Is there anybody who has got a question?
No, sir.
Right, so that's 5.3.2, that's 5.3.1. Right, let's move on to the last one. Right, I gave you the last, I asked you to do the last question on purpose because that's the next aspect that I was supposed to talk about after doing the numerical problems. So that will be your first question on proofs. We are going to carry on with the proofs as well tomorrow because it's a major part of your grade 10 geometry. All right. Now, before I carry on, I just want you to be aware of the following. If you go to your acceptable reasons under quadrilaterals, all right, we have got reason number 3, okay, reason number 3, reason number 5, reason number 7, and number 9. Number 9 and 10, they are used to prove that a quadrilateral is a palm. Okay? Now, this is part of the theorems that we did about, I think today it's a Tuesday, it was last week on Friday. So I went over those proofs that I concluded yesterday. Those proofs on theorems on proving that a quad is a palm are the ones that you are supposed to use to answer this question. So, your acceptable reasons are the ones that I just told you now under quadrilaterals. All the acceptable reasons which starts with if, okay, that's the converse now of a property of a palm. So if you say if the opposite sides of a quadrilateral are parallel, then the quadrilateral is a palm. Okay, if the opposite sides of a quadrilateral are equal, then the quadrilateral is also a palm. If the opposite angles of a quadrilateral are equal, then the quadrilateral is a palm. If the diagonals bisect each other, then the quad is also a palm. If one pair of opposite sides are equal and parallel, then the quad is a palm. So you have about 5 or rather 6 ways to prove that a quad is a palm. Right? In actual fact, it's about 5 ways to prove that a quad is a palm. And that's based on the theorems and their converses that I discussed last week on Friday and yesterday. Okay, so before you start doing this question, you need to be familiar with your properties of a palm and their converses. Okay, you need to be familiar with the properties of a palm and their converses. Now, in my case, diagram, I realized that there are 2 ways of doing this question. Right? There are 2 ways of doing the question. So I don't know whether you tried it and you were able to do it or not, but this is how I would approach the question. So in this case, we have 2 palms, A, B, C, D, and E, F, C, D. Okay? So you must be able to identify those palms. So let me just use different colors here. So we have the big one, that's A, B, C, D, that one there. Right? And don't forget this line is parallel to that. And then the other one is EFCD. So this is EFCD. Or rather, it's this one here. That's EFCD. And this line here is parallel to that. Okay? So I'm sure you can see that. All right. Now, in my case, I'm going to prove it. There are 2 ways. There's a short way and there's a longer way. All right? And the reasons that you can give in that case are going to be different in terms of the properties of a palm. So number 1, if we can prove that the diagonals, okay, if we can prove that the diagonals of AFDE bisect each other, we can conclude that therefore the quad is a palm. Also, if you look at this diagram here, we know that ED is going to be parallel to AF because CF is parallel to ED. Therefore, AF is also parallel to ED, which means already I've got one pair of opposite sides that are parallel. So if I can prove that AF is equal to ED, then I'll say the quad is a palm because one pair of opposite sides are equal and parallel. That would be the short way. So I'll start with method 1 for the solution. So this will be method 1. Okay? So with my method 1, I hope you can agree with me that if I say AF is parallel, sorry, CF rather, make sure you pay attention carefully as I go over this question. CF is parallel to ED. Okay? And this is given. Okay? Or we can say, because they are opposite sides of a palm, okay? But it's also given on the diagram. At the same time, CF is equal to AF. And the reason it will be diads of the palm. They bisect each other. Okay? So you can write this, or you can put the reason with a parallel line and put an M there like that. It's fine. Okay. Now, because CF is equal to AF, because the diagonals of palm A, B, C, D bisect each other, I can say, therefore, AF is parallel to, it's going to be parallel to ED. Okay? Do you agree with me on that, that AF is parallel to ED? Because point A, F, and C are on the same straight line. Okay? Let me indicate that. Point A, this point here, and point F, and point C are on the same straight line. So the whole line AC is parallel to ED. So I can give that as my reason here. Okay, I'll say why? Because AC is parallel to ED. Okay? Why am I saying AC is parallel to ED? It's because because AC, this AC here, right, is 2 times AE. Okay, so if AE is half of AC, it therefore means that AE is also parallel to ED because CE is parallel to ED. Okay, if you don't want to give a reason there, I think it will be fine. Okay, because you can see it on the diagram there. Any question there? Now, if you don't have a question, then it means you are following. So we now have a pair of opposite sides that are parallel. That is, AF is parallel to ED. Now we need to prove that AF is equal to ED. Okay? So I already wrote here that CF is equal to AF because they are diagonals of a palm bisect, right? So I now need to prove that ED is equal to AF. So I'll say EC is equal to ED. And the reason is opposite sides of the palm. Okay? The opposite sides of a palm are what? Are equal. EFCD is a palm, therefore FC, sorry, it's supposed to be FC, not EC. This is FC, right? So this is FC. FC or CF is equal to ED. Now, if I connect this statement and that statement, I'm sure you can see that both of them, or rather, let me write this one here as CF, because I wrote it on top there as CF. So I'll put CF here. Now, you can see that my two statements have got the same, they have the same line CF and CF there. So which means the left-hand sides of those two statements are equal, therefore their right-hand sides are equal. So I can conclude that therefore AF is equal to ED. Therefore AFDE is a term, right? My reason there, right, is going to be one pair of opposite sides equal and parallel. Okay? It's going to be a pair of opposite sides equal and parallel. Let me write it using another color. That's that one there. So my reason here will be pair of pair of opposite sides equal and parallel. That would be my reason. All right. Is there anybody who has got a question there? So everything that I wrote under method 1 will enable you to get your 5 marks. Because there are statements and reasons, so you'll be able to get your full 5 marks. So this could be a shorter way. The longer way, we have to use congruency. But I'll talk about that one tomorrow, because